Setting maintenance priorities for low-volume roads is a unique process. The purposes of low-volume road maintenance are to reduce the rate of deterioration and increase the life of roads, to reduce vehicle operating costs by providing good riding surfaces, and to keep roads open and safe all year round. The benefits of maintenance are well established. For example, during a 5-year period on a typical paved road, proper maintenance may cost $500 per kilometer per year. After 5 years, there may be a need to reseal at the cost of $9,000 per kilometer. This results in a 5-year cost of $11,500 per kilometer. Deferring maintenance is a mistake. The agency may save itself $500 per kilometer each year. But after 5 years, instead of resealing at a cost of $9,000 per kilometer, the road very well may need major resurfacing at a cost of $60,000 per kilometer to restore it to the same condition as if proper maintenance had been applied. Thus, for a maintenance expenditure of $11,500 per kilometer, savings of nearly $50,000 per kilometer could result from deferred rehabilitation costs. This has a benefit-cost ratio of 4:1. And it shows that by carrying out effective maintenance on a regular basis, 5 times the length of road can be maintained for the same price as by adopting a deferred maintenance policy. Key goals of rural road maintenance are to reduce road deterioration, decrease vehicle operating costs, and keep roads open and safe on a continuous basis. Even with proper maintenance, roads deteriorate with time. The rate of this deterioration will depend on the climate, the type and strength of the pavement, the strength of the underlying soil, the volume and speed of traffic, and characteristics of vehicles using the road, and the axle load of the vehicles. The effect of axle loading, and in particular of overloaded vehicles, on road maintenance requirements is considerable. A 10-ton axle causes approximately 2.5 times as much deterioration to a road as an axle load of 8 tons. More significantly, an axle load of 16 tons does 20 times as much damage as an 8-ton axle. It is clearly necessary for road maintenance purposes to know the value of the actual axle loading on a road, because minor underestimates can considerably shorten the expected life of a road and increase the maintenance inputs required. From a road maintenance point of view, there is considerable advantage in having appropriate axle load and seasonal load limitations legislation that is effectively enforced. But axle load enforcement must form part of wider legislation dealing with road transport operations as a whole. There are many problems associated with the enforcement of axle load legislation. But whether axle load limits are enforced or not, the most important thing for the road maintenance organization is to know the magnitude of the axle loads actually being carried by roads in order that maintenance can be planned realistically. Another key economic concern is reducing vehicle operating costs. If smoother and more consistent running surfaces can be provided by regular maintenance, fuel consumption and tire and parts wear can be reduced, which leads to a lower cost of operating vehicles on the road. The third key reason for rural road maintenance is to keep roads open on a continuous basis. Roads serve population centers and industry. And if roads are closed by landslides or culvert washouts, or because the surface becomes impassable during the wet season, there are serious social and economic consequences. A belief that a road may become impassable can be almost equally disruptive, since operators will not wish to risk getting their vehicles stuck or damaged. A case has been noted where, in one country, 40% of the vehicles fail to reach their destinations because of the state of the roads during the wet season. This resulted in closure of factories for several months. The method for setting up maintenance priorities on rural roads is simple. The first step is to establish the extent of the total maintenance requirement. This is determined by carrying out inspections to assess road conditions. The rates at which riding surfaces deteriorate are closely related to the traffic and vehicle characteristics. A simple road maintenance classification scheme based on traffic volume is shown here. It is not likely that all the necessary resources will be available to complete all work identified during the road inspections. As a result, priorities must be made. The first step is to estimate the total amount of work to be done. Maintenance work can be grouped under three following headings. Routine means required work performed at least once a year, such as grass cutting and grading. Periodic means required every few years, like regraveling. And emergency means non-programmed work in response to floods or other emergencies. It is necessary to allocate limited resources in the most effective manner. There are sophisticated maintenance management systems available to do this. However, a maintenance engineer managing low-volume roads may not have such a system available. Therefore, we recommend the following order of priorities be used. Priority 1, urgent work, which must be done when an emergency occurs. Priority 2, drainage work, since neglect of drainage has serious consequences. Priority 3, routine work on pavements. Priority 4, periodic work. And Priority 5, other miscellaneous work. Combining the basic priorities and the traffic counts results in a work plan like this. This is used to prepare a list of maintenance tasks in order of priority. Two main factors often act as constraints to properly maintaining low-volume roads: a shortage of experienced workers and inability to obtain items like equipment, materials, and parts. Such constraints can often be made worse by limited availability of equipment. In some developing countries, availability often ranges between 10 and 30%. This lack of availability results in three consequences. Output is reduced in activities like grading, where the equipment is a primary need. Output is reduced in activities where the equipment has a supporting function, such as transporting workers to a job. And when several pieces of equipment are required to work together, the effect on output is cumulative. In response to this situation, it is desirable to concentrate equipment on the most important tasks for which there are no alternatives, and take steps to improve equipment availability and use. As you can see here, labor-based techniques are often very inefficient. Another simple rule of thumb for managing rural roads has to do with allocating budgets. First, allocate funds to preserve the existing system. Then, try to maximize the return on investment. Only after allocating funds for maintenance and upgrading should any remaining part of the budget be allocated for new investment. Priorities should be as follows: maintenance, upgrading and reconstruction, and new construction. We've covered the basics of setting maintenance priorities for rural roads. The key goals are to reduce road deterioration, limit vehicle operating costs, and keep roads open. Setting maintenance priorities is simple. First, inspect road conditions. Then, do a traffic count to get traffic volume on each road section. A simple road maintenance classification based on traffic can be used. The work can be grouped under the following headings. Routine means required work performed at least once a year, such as grass cutting, patching, and grading. Periodic means required every few years, like regraveling. And emergency means non-programmed in response to floods or other emergencies. And finally, develop a work plan with maintenance tasks in order of priority. For more information on this or other IRF videotapes, write to the International Road Federation or call the numbers on your screen. Managing maintenance for low-volume, unpaved roads is unique. This course presents basic background details, typical maintenance problems, and typical maintenance activities associated with low-volume, unpaved roads. It also covers recommended procedures for developing and implementing simplified procedures for managing maintenance on low-volume, unpaved roads. Unpaved roads can be constructed using a wide variety of materials, too many to describe in one course. As a result, in this course, we will concentrate on one of the most common types of low-volume roads. As an example, gravel roads, which are typically 6 meters or wider. Maintenance managers encounter a variety of maintenance problems on low-volume gravel roads. Dust formation is caused by traffic. Raveling or disaggregation of the surface and loosening of the coarse aggregates also occurs. Rutting also occurs in all low-volume gravel road surfaces. Road surface erosion and potholes occur on gravel roads, especially when the longitudinal slope is over 4%. Gravel roads begin to deteriorate significantly when the longitudinal slope is over 7%. Corrugation is also typical in gravel roads. Roughness and upheaval distress occur in gravel roads because of subgrade movement or pavement instability. The typical engineering properties associated with the different types of low-volume gravel roads include different traveling speeds and vehicle weights associated with terrain, materials, and environments. Traveling speeds typically range from 25 kilometers per hour on curvy roads to 40 kilometers per hour on hilly sections. Maintenance is typically divided into 3 categories: routine, periodic, and emergency work. Routine maintenance activities include such tasks as gravel pothole repair with production rates of 8 to 15 square meters per day, culvert cleaning at the rate of 6 to 8 per day, hand ditch cleaning at the rate of 1 to 3 kilometers of ditch per day, and hand vegetation control with accomplishment of 0.5 to 0.6 hectares per day. Periodic maintenance activities include key activities such as regraveling. Crews typically can complete 250 to 300 cubic meters of regraveling each day. When doing surface grading, they can usually finish 3 to 4 kilometers per day. Using a grader for ditch cleaning, about 3 to 5 kilometers of ditching can be accomplished per day. About 1 to 2 culverts can be replaced per day, and about 1 to 2 hectares of vegetation control by machine can be done each day. The final type of work is emergency work. It includes landslide removal by machine, snow removal, and emergency pavement restoration. In order to accomplish these tasks in an organized and standard manner, it is suggested that basic work method statements are developed. A typical work statement for gravel pothole patching is shown here. In the example, to produce 8 cubic meters of gravel patching, it is necessary to use 1 hand compactor, 1/3 of an 8-ton dump truck, and a complete set of hand tools. The required labor for this activity includes 1 foreman, 8 unskilled laborers, and 1/3 of a driver. The maintenance work statement also gives a short description of the work method. You will also want to prepare a simple road and bridge inventory to provide updated information for maintenance planning in terms of volume of work and resource requirements. To prepare a proper inventory, you should include the following elements: identification of each road link, location of roadway features, coding and determination of the level of accessibility of the local population, and agricultural production. Engineering properties: length, width, type of road and terrain, number of culverts and bridges, type and length of ditches, and number and type of traffic control devices. Field evaluation: number and size of potholes, surface conditions, density and height of vegetation, slope failure hazards, performance of drainage facilities, types of soils, and material haulage distance. Other observations: special maintenance needs and suggestions for repair of pavement, drainage facilities, bridges, and other elements included in the right-of-way. One engineering team can inventory and evaluate approximately 50 kilometers of rural roads a day. The annual needs for gravel pothole patching would be calculated as follows. GPP equals the total annual amount of gravel pothole patching. LNG equals the length of road segments. MSL equals the maintenance service level of gravel patching in cubic meters per kilometer. And AF equals the adjustment factor of the current road condition. For example, 3.3 kilometers of road was evaluated as being in very poor condition. This required that the volume of maintenance work should be increased by 20%. In other words, the adjustment factor, AF, equals 1.2. The annual maintenance service level, MSL, of patching is 6 cubic meters. Therefore, the annual gravel patching needs of this activity for this road are 3.3 kilometers times 6 cubic meters per kilometer times 1.2, the adjustment factor, equaling 23.8 cubic meters per year. In addition to the work needs that were determined by the overall maintenance plan just described, other maintenance needs result from the following conditions. Deficiencies that were encountered during regular field inspection. Deficiencies that were noticed by crew foremen while performing another work activity. And requests for maintenance services by users, usually in the form of complaints and emergencies. Once an inventory is taken and conditions noted, you should begin development of the annual program requirements for labor, equipment, and materials. The annual program is based on total annual work volume for each activity, the daily production of each activity, and the requirements for labor and equipment needed to meet the daily production. For example, the annual work volume of gravel pothole patching is 3,500 cubic meters. The daily production is 8 cubic meters. Therefore, the annual crew days are 3,500 divided by 8, or 437 crew days. Therefore, the annual number of work days for this activity is 437 times 1, which equals 437 work days for the foreman. 437 times 8 equaling 3,496 workdays for unskilled laborers, and 437 times 0.33 equaling 144 workdays for drivers. Programming of equipment days is similar. The number of equipment days needed to perform activity 111R is 3,500 divided by 8, equaling 437 equipment days. Each equipment day includes 0.33 dump trucks. Therefore, the annual number of equipment days needed to perform activity 111R is 437 times 0.33, which equals 145 equipment days for the dump truck. A detailed monthly schedule enables the field crew to clearly understand its short-term maintenance work objectives. Experience indicates that without a sound, short-term schedule, crews frequently perform the easiest and most convenient tasks instead of those that are actually required. Experience indicates that work schedules for rural roads should be prepared for monthly periods. The actual preparation should be undertaken as a joint effort between the engineers and foremen who will be responsible for the work. Once the requirements and needs for labor, equipment, and materials have been determined, and before the schedules are prepared, consideration must be given to the following: timing, location, duration of work, and resource requirements. The preparation of the annual budget is the next task in the maintenance management procedure. This task is rather simple once the annual and monthly resource needs for equipment, labor, and materials are known. A detailed unit price analysis is performed to achieve an accurate cost estimate. A simple computerized cost analysis that includes the economic costs of equipment, labor, material, haul distance, and rate of production is completed to determine the direct cost for each maintenance activity. For each direct cost, there are other indirect expenditures, such as overhead, contingencies, supervision, and profit if the work is performed by a private contractor. Work monitoring and control is the last step in the process. The management of rural roads maintenance only requires the use of a simple field report that can easily be implemented on the site by the foreman or a senior crew member to report and control work. The purposes of the field reports are to identify and control the volume of work for each maintenance activity for each road, to update and adjust the rate of production for the different activities and road locations, and to update the maintenance needs and requirements for labor, equipment, and materials, and schedules of future work. The field report includes accurate and reliable descriptions of work location, work accomplished, personnel, equipment, materials, and any special problem observed during the actual field operation. This information can be easily stored in a personal computer and has been found to be very useful in increasing production and improving the quality of maintenance work. In addition, the field information is valuable for any statistical analysis regarding the conditions and needs of maintenance equipment. In this course, we've covered the basics of managing maintenance for low-volume roads. We covered typical maintenance problems associated with gravel roads, maintenance activities, road and bridge inventory, work planning, labor or equipment programming, scheduling, budgeting, and work monitoring and control. For more information on this or other IRF videotapes, write to the International Road Federation or call the numbers on your screen.